Hello and welcome to Chem 1B. This is our first lecture video. It'll be on our solutions chapter. We're going to talk about the property of solutions, things like concentration units, saturation, colligative properties, and some types of solutions. So let's get started.
We can have solutions in all three different physical states. They're just homogeneous mixtures of substances involving solids, liquids, gases. So for instance, we can have a gas in a gas. An example of that is air, right? Air is the mixture of nitrogen, oxygen, CO2, some water, as well as some trace gases like argon. So it's a big mixture. It's all homogeneous. It's an example of that type of scenario. We have a gas and a liquid. Carbonated beverages are an example of gases mixed with liquids. The CO2 dissolved in a carbonated drink is in solution with the water and sugar in most carbonated beverages. Gas in a solid. This is pretty interesting. A lot of solids have like these big empty spaces called pores, which we can infuse gases into. A lot of research is being done into this area for like hydrogen vehicles. Instead of having a compressed cylinder of hydrogen, which is kind of dangerous in a car, you can have a solid that absorbs the hydrogen in and siphon it back off in a much safer environment. Liquid in a liquid is things like motor oil, vinegar. Vinegar is a mixture of water and acetic acid, both liquids mixed together. We can have solid in a liquid. This is probably the major one that we've used throughout the semester with like dissolving our ionic compounds, solids, in water. Sugar water, ocean water, these are great examples of solids in liquids. And finally, we can have solid in a solid. These are like alloys, so bronze, pewter, 14 karat gold. These are all not single elements. They're mixtures of more than one metal. Like bronze is copper and tin. Gold, usually for jewelry, it's not pure gold because pure gold's actually pretty bad of a material to use for jewelry because it's a really soft metal, so it'll scratch just by like kind of touching it to another surface, or you could even scratch it with your fingernail. But if it was pure gold, so you mix in things like silver and copper into the gold to give it more rigidity and strength. Also, this is how you make the different types of gold too. So like rose gold, that's my favorite type of gold. It has a lot more copper in it than silver. And white gold has a lot of silver in it. I'm not sure what chocolate gold is. Probably a different metal entirely. But it's kind of neat. Anyways, let's talk about solution concentrations. That's the major point we'll be discussing in this chapter. There are a number of different concentration units out there, one of which is the mass fraction. We actually discussed mass fractions way back a while ago, but now we're going to use it with respect to solution concentration, which is our solute or solvent concentrate mass, doesn't really matter one way or the other, divided by the total mass of the mixture. Weight percent or mass percent is just the mass fraction, this guy, times 100. So if we wanted to do a problem involving this, we could say, hey, we have a sterile saline solution, NaCl in water. They're often used in medicine, and we'll talk about why we have to have the salt in the water and not just pure water going into our like IV bags later on in the chapter. What is the mass percent or weight percent of NaCl in a solution made by dissolving 4.6 grams in 500 grams of water? So if we want to do this, let's calculate our mass fraction first. That's going to be equal to 4.6 grams divided by the total mass, which is not 500, it's 500 grams plus 4.6 grams. This will give us our mass fraction for the solution, which is approximately 0.00911. There are no units for mass fractions. So now to get mass percent, I just multiply that number by 100. So 0.911 times 100 gets me sorry, 0.900, 0.009. Times 100 gets me 0.911%. And really, to 2 sig figs, this would be 0.91% is what we should have written down. All right, so that gives you an example of a new concentration unit, kinda. Let's talk about some brand new concentration units. Parts per million, parts per billion, parts per trillion. These are concentration units used when our solutions have very, very low solute concentration, or in other words, very, very, very low mass fractions. This is when we have like a trace amount of a substance present in a solution. For instance, like lead in water. You don't want to drink water with lead in it unless it's a very, very small amount, probably in the terms of something like parts per million, parts per billion or so. So how do we calculate these units, or what are they defined as? Really, parts per million is your mass fraction times a million, or 10 to the 6, right? So this is just times a million here. And this is our mass fraction here. And that's pretty much the case for all of these. Parts per billion is going to be our mass fraction again, times, this time, a billion. And parts per trillion is going to be our mass fraction times a trillion, which is 10 to the 12. You should know their symbols, PBM, PBB, PBT, are our different symbols for these units. And if you have any questions, always just feel free to ask.